Hey, this is Donald from Padlock Technologies. I am the owner and principal consultant. So not only do I own the company, I actually do the work as well. Today, I'm going to be talking about SASE, just giving you an overview of what it does and how it can help your company if you want to actually bring your WAN infrastructure into, the next generation and not use traditional WAN technologies. So let's go to the whiteboard and give you a quick overview of what SASE does and how it can help you. All right. So first, let's talk about what SASE is. Let's get the definition out. So SASE stands for, let's look at SASE here. SASE stands for, there's two components. There's secure access and secure edge. And you got to break those two up. So if we break them up, let's put secure access on this side and secure edge on this side. So what secure access does, this is your VPN as a service technology. So what this does, this is technically RA VPN or remote access VPN. This allows users to connect to your internal resources through VPN as a service. So it removes what they call the VPN head-in or the RA VPN head-in from buying all this equipment. You don't need to buy multiple boxes and stuff like that. You can just use SASE, create your RA VPN, and then people will just connect to SASE. The good part about that is you can position multiple VPN headings in different locations. And what that does is it reduces the latency from where the person is to where they're connecting. So say if you're in China, you can connect to a VPN header in China or in that region compared to having to go all the way back to California or somewhere in Indiana, somewhere in the Midwest or Atlanta, something like that. And you can have latency because you're, geographically so far away. The other thing about secure access, and this is the big one here that everybody keeps talking about, is ZTNA, which is zero trust in a nutshell. So, what zero trust does is it allows you to authenticate a user before they can actually get to the resource. Now, this does not mean your authorization, so to speak, in your traditional sense. This just says, hey, before you can access a resource, you need to authenticate. We need to prove that that's you, and then you're allowed to access it. So, in terms, I'll look at it like this: we have a web app that you want to get to. So, what ZTNA would do is say, okay, before you can get to the web app, you're going to get a login screen and you have to prove yourself. Now, that is this login screen will be browser based, and then there's the ZTNA module. Now, this is Cisco SASE right now that I'm talking about, by the way. There's a ZTNA module that will prompt you to say, hey, before you can get to this resource, you need to sign in. So, login, traditional login, we will say is browser based, and then the module is client based. Either way, we have the web app here that you're going to have to log in again. So you're going to have to log in again to get to this this web app. Now, the reason why you have to log in again because it's not a good security practice to just use ZTNA as the front end and say, okay, you'll log in there, and then you just have infinite access, immediate access to the web app. You should be logging again now at the web app to say, okay, now you can get to the database. Because if you just leave this wide open, all kind of stuff can happen. So that's the secure access part of SASE. Now, the secure edge part of SASE is your DNS layer security, your web layer security. This is like your internet stuff, right? That's your secure edge. So if you package all this up here, now there is firewall in here as well. But if you package this all up, this is when people are trying to get out to the internet. So you may have, you know, remote users. So we'll say remote users, branch, and headquarters. Now they're all trying to get to the internet. Now the problem in the traditional sense, when you're talking about traditional WAN technology, is all three of these different components they suffer from different policies. So different policies, which causes a huge problem here, because if your policies aren't unified, what ends up happening is there may be a security breach somewhere or a hole somewhere in here that allows the bad guys, I'll say BGs, to compromise one of these three sources. And once they're in here, they can pretty much pivot. Now, remote, not so much unless they do remote access VPN. Then they can pivot from the remote machine using RAVPN to pivot into your internal network. But let's say somebody in the branch in the HQ is compromised, well, they can pivot from whatever network that machine that's compromised is connected to. So those are the two things that if you break SASE up, you have secure access, secure edge, and these are the components that come into it. So I'm going to give you an overview of the entire architecture, and then in my next video, I'll actually show you a side-by-side comparison of just SASE in general. So let's go to another screen now. Let's draw this out. So we have this big box here would be the SASE cloud. SASE cloud. This has all the components that you connect to. So there's going to be three ways you can connect to SASE. We're going to say client-based. So this is CB, client-based. Then we have browser-based. So we'll say BB. And then we have your traditional headquarter location-based stuff. So then there's two components on the SASE end that you would actually pop out of. So for internet access, you would pop out of NAT. And then for private access, you would pop out for private access here, right? So your internet would flow out here for iNet. And then your private resources can be cloud-based resources, so cloud applications. And then you have data center applications, or DC apps, which are considered private apps. Okay? So those are the two sides. You have how people that need to access resources on the left, and the resources are on the right. So when you connect to the SASE cloud, there's a couple ways you can do it. When you have the client-based module, you are using secure client. So they are going to be accessing it via secure client. And there's two ways you can do it with the secure client. So there is VPN, ZTNA. All right. So that's what users with client-based modules are going to do. With browser-based, you can only do ZTNA, right? So browser-based is only going to be 80 and 443. Client-based can actually use this thing called Quick, and that will do anything that is not 80 and 443. You can technically do 80 and 443 and Quick, but technically you don't need to do that, right? So that's going to access resources that way. For the HQ, that is going to use tunneling. So you're going to do your typical IKEV2 tunnel, IKEV2, VTI tunnel. So this is going to be a static VTI. If you know what a static VTI is, basically it's a tunneling mechanism that you go into the SASE cloud. Now, in that SASE cloud there, for the tunneling piece, there's this thing called a service redirector, right? And that tunnel comes into here, and then it sprouts out into a couple locations. So there is a thing called a firewall. There is a virtual firewall in secure access that you can go to for non-web traffic. I'm just saying non-web traffic. So this is your, if you wanted to, SSH, RDP, stuff like that. If you want to go to the web, though, it goes into another capability. There's a whole bunch of capabilities here. And that could be, IPS inspection. That could be SSL decryption policies, and there's more policies. I'm just going to put 3 in here. And then you can do what other policies are, web policy, right? Web policies. Then after it comes out of your web policy, after that stage, there is another stage for things like CASB, which is, cloud applications, Office 365, Google, Box.com, stuff like that. Then there's DLP as well. DLP basically is preventing you from sending sensitive information. Most people don't have a DLP strategy, and they should. But things like, hey, if you're going to email, or you're sending out social security numbers, or you're sending out credit card numbers, DLP should be able to catch that and stop that transmission from happening. After it gets through all of that, then it goes to this NAT, and then you get out to the internet. That is basically SASE in a nutshell. Now, or at least for the website. Now, if you want to access private apps like cloud apps, things that are in Azure, AWS, Google Cloud, if you use that, or DCs, what you can do is there's 2 ways to do it. I already said it out the way. I said the first way was you can use SASE to tunnel from here all the way to these private apps. So you'll just create a tunnel to SASE Cloud. SASE will kind of stitch that together, and then you'd have a site-to-site tunnel. Now, I know most people do not want to use SASE Cloud as your site-to-site mechanism, but it's good to use as a backup. So if you have a main site-to-site route-based tunnel that goes down, you can technically use SASE to get to that resource, right? And it's just a routing thing at that point. The other things you can use is these things called resource connectors, so RCs. So what RCs do is they create a outbound tunnel back to SASE. So I'm just going to go back to the RC. They create an outbound tunnel back there. And what they do is they say, hey, SASE Cloud, I know about apps 1, 2, and 3 in the cloud, and I know about apps 1, 2, and 3 at the private data center. So if anybody from a client-based or browser-based wants to access these resources, and this is so far the only thing I've seen is either client-based or browser-based. This doesn't technically work for the site-to-site tunnels at the HQ. But let's talk about client-based and browser-based. You would say if you need to get to a resource that's connected to a resource connector, you put the FQDN or whatever, that would be tied to the resource connector, and then that traffic would be tunneled to the resource connector, and then that would be proxied to these other applications. So think of this as just a proxy, right? You're not actually talking to the applications directly. You're talking to the resource connector, which talks to the application directly and then proxies that traffic back to you. Now, why would you do this? Well, you would do this if you don't want to create tunnels, right? You don't want to create tunnels. You kind of have like a web application or something like that. And you just want to do the resource connector. You don't have time to build, ICAF2 tunnels all over the place into the SASE Cloud. And you just want to use the resource connector to get to the resource and then do what you got to do and get out. Now, you can still use ZTNA for this as well. You just need to point it to the resource that you connect to the resource connector. Now, these are VMs that you would need to have a virtual environment for, and then you would just in the actual cloud itself say, this app is connected to this resource connector, and then that's how that communication would start. That's a wide overview about what that is. If you want help and you want me to show you exactly what that looks like, I'll leave some contact information at the end so that you can get in contact with me and I can actually give you a demo of that. So last but not least, what are the use cases? Again, what are the use cases of SASE? So use case, let's go use case number 1. So use case number 1, the big one is ZTNA, right? You want to be able to access your applications from anywhere in the environment, anywhere, in the WAN, and you want to be able to authenticate users before they get to the application. So I need to trust you before you even see the web browser place. That's a big thing. A lot of people want to get into that ZTNA strategy. This is a simple way to get into that. Number 2 is, I would say, VPN as a service. This here is you want to consolidate. Hopefully that's right. Let's consolidate VPN headends. Right. Now, what this does is it reduces costs. It reduces capex. Actually, it reduces your capex because you don't have to buy the equipment. Now, opex you still have because somebody has to operate the SASE and stuff like that. So it doesn't really reduce opex so much, but the capex definitely you don't have to buy a whole bunch of boxes, right? So you don't have to do that. You just transition that over to Cisco Secure Access. The third one is your traditional edge security, right? Edge security, everybody gets the same internet edge policy, and that policy follows them no matter where they go. Follows users no matter where. No matter where they are. So what's good about this is as long as they're using their corporate laptop, doesn't matter where they are. They're going to always go through your SASE policy, so they can't bypass it. And that's kind of the critical thing. If someone's sitting behind, if they're in your corporate infrastructure using their corporate laptop, the minute they leave your corporate infrastructure, technically they're not enforced by your policy anymore. That's exactly how people get compromised because they take their laptop, they go somewhere else, they get infected with something. EDR is not your, it's not the end all be all. It's just it's one thing in the layer of defense, but it's not the end all be all. So they'll go and get compromised using public internet or something, and then they'll come back into your environment, and then everything goes up in smoke because now you're compromised all over the place. Well, if you have a unified, and let me make sure if you have a unified INET policy, they can't get around that. So say you block a certain site in HQ or at a branch, when they go home and try to access that same site, now that they're off premises, they're getting blocked for the same thing because it's the same policy. The policy has now been moved up a layer. It's not local anymore, it's global. And last but not least, I would say, the site to site connectivity. Very rare that people do this, but it's a backup. I would call this a backup to main VPN, main VPN, and that's site to site. I'll say it's the backup to that. So those are the use cases. That was a quick overview of how SASE works. What are the two components? How you break those apart? Kind of the architectural layout of how Cisco Secure Access works. Now, there's plenty other SASEs, but I know Cisco Secure Access, so that's the one I'm going to teach. So if you actually are interested in seeing how we can implement this for you, you can reach out to us at www.padlocktech.com. Actually, I'll write that down here. You can reach out to us, www.padlocktech.com, and we can have a quick consultation, see what you're doing, see how we can use SASE to kind of secure your environment. And then, hopefully we have a project from there. So this is Donald Hessel again with Padlock Technologies. Here's to the first video. I call them Notepad Nuggets. Hope you like it, and see you soon.